My volcanoes book strikes again. I bought this giant coffee table book about 3 years ago. I'm on page 123. Listen to this. According to Georges Louis Leclerc de Buffon, who lived from 1707 to 1788, the Earth was a star that was cooling. There you go. I found another person. But turns out it wasn't him that actually said it. I looked up Buffon's work, and he writes here on page 144 of volume number 1 of his natural history book, which was published, I think, in 1788, I believe, or might have been a little earlier than that. He says here, in the Acts of Leipzig in 1783, page 40, the famous Leibniz published a scheme of quite a different system under the title of Proto-Gaia. The Earth, according to Bourget and others, I don't know how to pronounce that, must end by fire. According to Leibniz, it began by it, and it has suffered many more changes and revolutions than is imagined. I know exactly what he was talking about. The greatest part of the terrestrial matter was surrounded by violent flames at the time when Moses says light was divided from darkness. Now, they sort of go off on the biblical creationism type stuff, but just ignore that. This is where it gets interesting. Quote, the planets, as well as the earth, were fixed stars, luminous of themselves. After having burnt a long time, he pretends that they were extinguished for want of combustible matter and are become opaque bodies, meaning you can't see through them. There it is, ladies and gentlemen. Gottfried Leibniz said Earth was an ancient star, as well as all the other planets at some stage or another of evolution. The dude that invented calculus, independent of Isaac Newton, a pretty smart fellow if you ask me, says exactly what I'm saying, and did so 83, 70, 237 years ago. This is what he was talking about. The Earth and all the planets were really hot and bright, just like the sun. They were fixed stars at one point. They weren't wandering stars. They're wandering now, but we all know better. And as well, it's kind of leading me to understand that Leibniz himself, the guy that basically created calculus independent of Isaac Newton, there are two aspects of calculus that I'm going to need to learn how to apply with this theory, and it's definitely going to be really hard, but I think with some time and energy and effort I can get to the bottom of this. I took calculus in college, but I don't remember a lot of it. Differential equations, finding slope of the curve, all that stuff. But for those who are new to calculus, so you have integral calculus, and then you have differential calculus. Now, integral calculus is where you have a graph, and you basically have to find the area underneath a curve. And that will be useful for populations, for finding how many objects there are. You can find basically any curve in here and find out populations from this graph. Now, I know it's not exactly mathematically worked out, but integral calculus sometime down the road is going to help me out with that. And we'll be able to measure populations of stars, how many there are, given which curve I want to measure, and under which line and whatnot. I can go anywhere I want with that. And differential calculus has to do with the rate of change, which you find the slope of the tangent, or tangent of the slope, I should say. So tangent of the slope, you have the instantaneous rate of change, and this is to signal a transformation curve on this graph. Transformation curve is like that purple line, the Taylor threshold. And you can find the how fast a star evolves using calculus, which then basically you have to learn how to plug in functions, and functions is that fx number right there. Given x is a certain number, fx is going to be the y, wherever it is on the y portion of the graph. As well, you can combine them together to find slopes of the tangents, and you can also take two different functions, and you can find the slope of the curve. You can find the slopes of these curves, and then you can calculate certain areas. Say like right here would be say maybe gray dwarfs, and then ocean worlds over here. You can find out how many gray dwarfs and ocean worlds there are, and then up here you can figure out the hotter younger stars, where they are, how many of them there are. But calculus is definitely going to be a part of this theory's future, and I am not looking forward to it at all, because calculus is definitely one of the most difficult maths anybody could ever study. And yeah, I guess that's it. 1783, Leibniz. So basically 100% certain that the very essence of stellar metamorphosis is over 230 years old. It's at least as old as the United States for the most part as a country, which is really crazy to think about. It's just the astronomers these days, they still sort of have their heads in the sand. Maybe if they look up some history books and do some digging like I have, they would, oh yeah, they would wake up, but I don't know if that's ever going to happen. Hi, Celeste.